All right, guys. Hello. We are going to be doing today's notes via video since we had so many people absent last class. Just due to being sick and whatever people had going on. So today we're going to intro to our next unit, which is going to involve something called a unit circle. So starting off, your unit circle is, think of it kind of like a volume dial where you're like twisting it up or down. So we're going to be measuring angles going around the circle, and all angles are going to be measured from the positive x-axis. So the positive x-axis is going to be here. Okay, so this is your starting value. And then if you are measuring a positive angle, you are going to go this way for a positive angle. Okay, so think you're going up and around is positive. Now, technically, okay, that is counterclockwise. Okay, but I want you to think about it as a positive angle, you're going up and around. Okay, so if I wanted to measure 45 degrees on this circle, I would say, okay, well, if I go all the way to here, this would be 90 degrees. So if I want to only do 45, that would be about half of it. So 45 degrees, my dial would be turned from here to here. That would put me in, let's draw your quadrants up here. 1, 2, 3, 4. So I would still be in quadrant 1. Okay, next question. I want to label 100 degrees. Well, then I would say, okay, well, if this is 90, from here to here, then if I want to twist to 100, I would have to go a little bit past there. That would be about 100 degrees, because I'd have to twist all the way to 90 plus a little bit more. That would place me in quadrant 2. Okay, next one I want is 200 degrees. So let's do our standard kind of 90-degree multiples. So 90 degrees is perfectly up. If I twist the dial halfway around, this would be 180 degrees. And then if I do 90, 90, 90, that would make this 270. And then if you happen to go all the way around the circle, a full rotation, that would be 360. Okay, so if I want to label now 200 degrees for part 3, okay, well then I would say, okay, where will 200 fall? Well, if I go all the way to here, that's 180, but I have to go a little bit more. That means 200 degrees would be about right there, where I'd have to rotate all the way around to 180 and then keep going. Okay, that puts me in quadrant 3. Okay, next I want 270. Okay, so I noticed that 270 would be twisting my dial all the way to perfectly straight down. So it says, in which quadrant is this angle? You would say that you're technically on an axis, which means you're not in a quadrant. Okay, technically you're between quadrant 3 and quadrant 4. Okay, but you're really not in either quadrant if you are along that axis. Okay, all of these angles we just did are positive. So now let's talk about what if you need an angle that is negative, okay? Then rather than you going up and around on the circle, you're still gonna start from here, which is the positive x-axis. But rather than you going up and around for a positive angle, if it's a negative angle, you're going to rotate this way. So think positive is up and around, negative, you're turning that dial down, okay, which would be clockwise. So if we measure, okay, negative 35 degrees, well, then I want you to think about, remember, I'm always starting from here. If I go all the way to straight down, that would be negative 90. So if I only want to go negative 35, that would be maybe like somewhere right here. Where you're twisting it a little, but you're not going like all the way to 90. You're just going 35 degrees. So that would put me in quadrant 4. Because remember, it goes 1, 2, 3, 4. Next one I want is negative 110. Well, think about if here to here, this is negative 90. Then negative 110 would maybe be like right here. Okay, which that would put me in quadrant 3. Okay, so 110, I would go past 90, but I wouldn't make it all the way to halfway around the circle, and that would be 180. So now let's say I want to make it all the way to negative 200. Well, then I would go always starting from here. You would rotate around to negative 180. And then if I'm trying to make it to negative 200, I would have to go even a little bit past there. That would be negative 200 degrees. Okay, because you'd have to hit your 90-degree rotation. You'd go all the way to 180 and then even a little bit past that to get to 200. So that puts me in quadrant 2. Okay, then your last one says to label negative 90. Okay, well, I see that I actually have already labeled that here. Negative 90 would be right. Okay, so that would be on the axis, technically not in a quadrant. Now, I do want you to notice that your negative 90 degrees ended up perfectly straight down, and so did 270. Okay, you'll notice that both of these angles ended in the exact same spot on the dial. That whether I go 3/4 of the circle this way, or 1/4 of the circle this way, either way, my dial would perfectly end in the down position. So let's fill in the blank down here. It says, notice that 270 and negative 90 ended up in the same position on the unit circle. Okay, if you have angles that terminate in the same position, they're called coterminal angles. Coterminal angles. Okay, so go ahead and turn the page. Okay, because we have this phenomenon where angles can basically end up in the same spot, we have standard position, which is going to be from 0 to 360. Okay, so an angle in standard position is going to be measured between 0 and 360 degrees. Any angle that is not between that, okay, is going to be either over rotated or under rotated, and you want to get it back into standard position. So if I want to end up in the same position, I'm going to add or subtract 360 degrees. If your angle is rotated, okay, which means that they are too big, then you're going to minus 360 to put them back into standard position. So here's what I mean by that. I want to find a coterminal angle. Remember in your head, that means same place on the circle. Same position on the circle. As 400 degrees. Well, then I would say, okay, here's my circle. 400 degrees, I'd have to go a full 360 and then plus a little bit more. That's why it's considered over rotated. So in order for me to fix it, I'm going to take my 400 degrees. I'm going to minus 360 degrees off. Whatever's left over would be the same position. So it would be 40 degrees. Okay, where standard position is, again, like I said, between 0 and 360. Okay, then it says to find a negative coterminal angle. Well, if I want an answer that's negative, I'm going to take my 40 degrees and I'm going to minus 360 more until I get a negative value. So negative 320 would put me in the exact same spot. So we minus 360 to get 40. We minus 360 again until we got to negative 320. Okay, but all three of these places on the dial would be the exact same position. Okay, that I could go just 40. I could go 360 plus 40 more, I'd end up in the same position, or I could go negative 320 and I would still end up here. Okay, same thing for 920, put it in your calculator. If I do 920 minus 360, I notice that my angle is still too big, then I'm gonna minus 360 again. And then I get 200, 200 is within my 0 to 360 window. So let's write that down. We're gonna minus 360. That gave us 560, but it's still too big. So then we're gonna minus 360 again. And that gave us 200 degrees. Okay, which standard position, remember, is 0 to 360. Okay, then it says, what about a negative coterminal angle? Well, then I'm gonna have to minus 360 again to get a negative answer, which would be minus 160. Is negative 160. Okay. Now let's say that rather than your angle being over rotated, which means it's too big, let's say that your angle is under rotated or too small. If your angle is too small, then to fix it, you're going to need to add 360 to put it back into standard. So let's say that our angle is negative 225. Okay, if I were to graph that on my circle, negative 225, I'd go back 180. 225 would be somewhere in here, because remember, I know that perfectly up is 270, and I'm not going to make it around that far. If I'm stopping at 225, then I know I'd end up in this quadrant here. But if I want to be in standard position, this number needs to be between 0 and 360. So I'm going to type in negative 225 and I'm going to add 360. So let's do plus 360, and that gave me 135. Now notice 135 is already in the window that we want from 0 to 360, so that would be our standard position. Next one, I want a negative coterminal angle. Well, then I'm going to take my negative 225 and minus 360. Okay, so remember, if it's a negative coterminal angle, the answer has to come out negative. So I can't add it, I'd have to subtract it. So negative 585 would end up in the exact same position as negative 225. So all three of these, your dial would end in the same place. Okay, one more left like that. We have negative 850. I want standard position, then I'm going to add 360. And I get negative 490. Notice that's still too small. So I'm going to add 360 again. Still too small. Add 360 again. And now that's just right. Remember, our window is 0 to 360 degrees, one full circle. So I'm going to go ahead and write that down. We added 360 and we got negative 490, which is still too small. So we added 360 again, and we got negative 130. Which was still too small. So then we added 360 again, and that gave us 230, which is just right. Okay, last little part of this is a negative coterminal angle. Okay, well then technically for a negative coterminal angle, I could use either one of these. Okay, so I could use negative 490 or negative 130, Now, I also could have taken my negative 850 and minus 360. Okay, which means negative 1210 would also be coterminal. Okay, so remember that because this is a circle, you're gonna end up basically with unlimited ways that you could get to that angle. Okay, this would be just backwards 130. This would be you're going a full circle backwards and then even more after that. Okay. All right, the last little bit of this is going to involve the unit circle. And so without really super getting into geometry, the unit circle comes from two special right triangles that you should have covered in geometry. So the first one is a 45, 45, 90. And then the second one is a 30, 60, 90. Okay. I'm gonna draw
Good
both.
morning, Eagles. Today is Monday, February 3rd. I'm Sabrina, and I'm Luck, and you're listening to Eagle Ear. Please.
Okay, sorry, I didn't want to talk over the announcements. So essentially, we're gonna use these two special right triangles to construct this big giant. Oh, sorry, you can't see my screen. Okay, so we're gonna use these special right triangles to essentially construct this big giant circle, which is the last page of your packet. Okay, right here. So 45, 45, 90 is a special triangle that you should have covered in geometry, where essentially if both of these legs are x, then the remaining side is x root 2. Okay, and the reason that happens is that if you have two 45, 45 degree angles, then your two sides have to also match each other. So we're gonna use that information to construct a triangle where your hypotenuse will be length 1. So using this first little grid here, I want you to draw in 45 degree angle would be this center one, because remember, if this is 90, then 45 would be perfectly in the middle of that. And then I want you to cut it straight down to the x-axis, just like we've been doing for this last kind of. So you should have just made yourself a little triangle. Okay, on this triangle, you want your hypotenuse to be 1. Okay, so the question is, if that hypotenuse is 1, then what would that make the other two sides here and here? So let's start off by doing a little Pythagorean theorem. So I know that whatever this side is, plus whatever this side is, okay, if I do Pythagorean theorem on it, it has to equal 1. So we're gonna do a squared plus b squared equals 1 squared. But then we know, based on this proportion, that these sides have to match. So I'm going to change this to be a squared plus a squared again. Okay, and like I said, the reason for that is that if these angles are both 45, then these sides are both 45. So that means that I have a squared plus a squared is 2a squared. 1 squared is just 1. We're trying to solve for a here. So divide that 2 across, which means that I have a squared equals 1/2 square root of that. Now, when you take the square root of a fraction, you're going to take the square root of the top and the bottom. So the square root of 1 is 1, but the square root of 2 is going to have to stay the square root of 2. And then we know, okay, that based on our rules for square roots, they're not allowed to be left on the bottom. So we're going to have to repeat our root 2 here and here, which means that our a is going to be 1 square root 2 over, that would be regular 2. Okay, then I want you to label that onto your triangle, that this is my root 2 over 2, and so is this. Okay, because again, those sides have to be the same. So with that combination of this distance and this distance, you are going to label this ordered pair as my x is a root 2 over 2. My y is also a root 2 over 2. Okay. From here, I want you to take your circle. Okay, it's the back page of your packet, and I want you to just pull that circle off. Okay, while we draw on this circle, I want you to do your very best to write neatly. Otherwise, you're going to have a lot of trouble this whole unit reading your own handwriting. So we said that 45 degrees is perfectly down the middle. That would be this one. And then we just found that this ordered pair should be root 2 over 2, comma, root 2 over 2. Okay. Using symmetry, and also I want you to label on here. We know that our radius is always. Okay, but if I have a triangle here, and I flip it across the x-axis, or sorry, the y-axis, that would put me here, which would be this triangle. But notice that because I'm on a circle, my radius is still 1, which means that these triangles would essentially be congruent. The only thing that would change is that instead of me going to the right and up, now I'm going to go to the left and up. So label this ordered pair right here as negative root 2 over 2, comma root 2 over 2. Because instead of going to the right and up, now I'm just going to the left and up. Okay, in your bottom quadrant, I want you to pick the diagonal that's right down the middle. That would be this one. And we know that this ordered pair will be exactly the same, except that I'll be going to the left and down. So draw your ordered pair. It's negative root 2 over 2, comma, root 2 over 2. And then we're going to do one more. Make sure you're perfectly down the center of the diagonal. Okay, that would be right here. And for this one, I'm going to go forward and down. So my x is going to be positive root 2 over 2. But my y is going to be negative. Okay. Now, there are a few other dots that we can go ahead and mark right now. Remember, we are marking x comma y's. So if I wanted to place, let's say, this dot on my circle, remember that I know that my radius is always 1. So if I want to end in this position on the circle, that would be 1, 0. If I wanted to end on this part of the circle, rather than going to the right one, I would go to the left one. That makes this negative 1, 0. Now think about, what if I want to end up here at the top of the circle? Remember, my radius is 1, but this time I want to go up 1. Well, then that would be 0, 1. Where I'm not moving to the side at all, I'm just moving straight up. Which means that the bottom of the circle would be 0, negative 1. Okay, so at the bottom of the circle, you're going to put 0, negative 1. Okay. Then once you have those pieces labeled, go ahead and go back to your notes. Okay, the other type of triangle that you should have learned when you were in geometry is the 30, 60, 90. So the 30, 60, 90 special right triangle looks like this. And if this is your x, this was 2x. The third side was x root 3. So essentially what we know is that whatever this side is, the hypotenuse is always double. So let's come down here to our little triangle that we've drawn. 30 degrees is going to be less than 45. So if 45 is perfectly down the center, then 30 is going to be here. This is 30 degrees. and then you're gonna connect back to the x-axis. There's your triangle. Now, remember what I said, the hypotenuse on this triangle is always 1. So I want you to think about for a second that if my slanty side here is 1, then this leg has to be half of that. Okay, let me show you again on this triangle. If this is 2x, I would have to cut it in half to get myself back to x. So go ahead and mark a 1/2 here. And then your third side, okay, whatever your x is you're just gonna multiply by √3. So that means that in my triangle, if this is a 1/2, then this is gonna be a 1/2 times √3. So go ahead and put a 1/2 √3. Okay, and then we should know just from, whatever math, okay, that essentially your 1 and your √3, you don't have to write both. You could just put √3/2, which is how we're gonna write this one here. So my x is a √3/2. My y is a 1/2. My x is a √3/2. My y is a 1/2. Okay, this is gonna go everywhere that you're 30 degrees off the axis. So come back over here to your circle. And I'm gonna mark 30 degrees with that ordered pair, which is √3/2, comma 1/2. So 30 degrees is here. I'm connecting back to the x-axis, that would be here. And then my ordered pair was √3/2, comma 1/2. Okay. Now let's add in a couple more details to your circle just to kind of make this next part easier. So this would be 0 degrees because this is where you're gonna start your measurement. Remember, we're always starting from the positive x-axis, that's right here. And then remember, for positive angles, we're measuring this way. So we said that this is 30 degrees. We said this is 45 degrees. And then we know that halfway across the top of the circle, that would be 90. Okay, if I were to go all the way to here, that would be 180. So let's say that I want to find my next 30 degrees off the x-axis. So let's say that I want to find this one right here. Okay, think about if this is from here to here is 180, and I want to stop 30 degrees short of that. Here to here is a 180-degree rotation. I want to stop 30 short of that. Then that would make this 150. Okay, so think about that if that makes sense. But if I want this to stay a 30-degree angle, I would need to stop at 150. Now, if my original ordered pair is √3/2, comma 1/2, then if I'm going to the left and up, I would need to change my √3/2 to be a negative √3/2, comma 1/2. Okay, because I'm still doing basically the same triangle, but I'm reversing the direction. Okay, and then I'll have the same thing that will happen down here. Okay, if you want to draw in your 30-degree angle, I would want to go like this. But now think about, I'm going all the way around to 180 because I always start here. And then I want to go 30 more degrees than that. That would put me at 210. And then if that's 210 degrees, let's write our ordered pair. I'm going to go to the left, negative √3/2. And then I'm going to go down. Okay, then we have one more 30-degree angle to mark. We said this is 0, 90, 180. Perfectly down is 270. which means that all the way around would be back to 360. But let's say that rather than me going all the way around the circle for the full 360, I want to stop 30 degrees short of that. Well, then this would be 330. And then think about it. I'm still going to go to the right √3/2, but now I'm going to go down a half. Okay, but I know that it's still a 30, 60, 90 triangle. Okay, because I'm 30 degrees away from 360. Okay. So that would be your 4 30, 60, 90 triangles. Okay. Let's go back to your notes. Turn the page. Okay, the last triangle is going to be a 60-degree triangle. And so think about this is 30, 45, this is 6. And then I'm going to connect back to the x-axis. Now, if this bottom corner is 60, then that means that your top corner is now the 30. So if you think about it, this is really the exact same triangle, but just tilted sideways. That if my 30-degree angle is here, then this is my x, this is my 2x, this is my x√3. So we're going to essentially have the same two sides, they're just flip-flopped. That if my hypotenuse is always 1, my short side is half of that, and my other side is half √3. But then remember, we know we would never write it like this, you would just put √3/2. So my ordered pair would be a half comma √3/2. Okay, then from there, we're ready to put that on your circle. So go ahead and look at your circle, find 60 degrees. Okay, so this is 30, 45, this is 60. And my ordered pair was this one, but backwards. So now it's 1/2 √3/2. Okay, and then if you want to draw in your triangle, it would look like this. Okay, so from there, let's do our repetitions. So if this is 60 degrees, then this would be my other 60 degrees. But I'm going to go all the way to 180 and then be like, oh, wait, that's too far. I need to back up 60 degrees. That would put me here at 120. And then my ordered pair would be negative 1/2, comma, √3/2. Because notice it's still the same two distances, but instead of going to the right a half and up, now I'm going to the left a half and up. Okay. Same thing down here. This would be 60, 120, 180. If I add 60 degrees to that, that makes this 240. Okay, you could also think about that you'd be 60 degrees past 180, but then still 30 shy of 270. And my x and my y would both be negative in this quadrant because you're going to the left and down. And then your last one here, if this is 270, that would make this 300. So that you're 60 degrees shy of 360. And that would be positive 1/2 because you're going to the right and then down. Okay, then the last measurements we have to put into this are the greens that I just basically forgot to write. So if this is 300 and this is 330, perfectly half of that would be 315. If this is 210 and this is 240, perfectly half of that would be 225. If this is 120 and this is 150, that's 30 degrees difference, then I want to go in 15 between that would be 135. just like over here, it's 30 to 45 is 15, and then 15 more is 6. Okay, so this little hellish triangle circle thing we made, we're gonna now use for your homework. So if you'll take a look at the last questions on your notes. Okay, the purpose of the unit circle that you just made is that this is a very easy graphic for evaluating sine and cosine for the angles listed around your circle. So whenever you are finding a cosine value, okay, that's going to be the x of that ordered pair. And whenever you are finding sine, that's going to be the y value of that ordered pair. So let me show you what I mean. If I want the cosine of 60 degrees, I'm going to go on my circle to 60 degrees. So I would go, whoop, here's 60, here's my ordered pair. And then for cosine, I'm going to pick the x. So it would be 1/2. Then for sine, I would pick the y. So remember 60 degrees was here, it'd be √3/2. Okay, and then if you want to put this one's the x value, this one's the y value. Okay, next one, I want cosine 120. Find 120 on your circle. Okay, so I see 120 is here. My x is -1/2. My y is √3/2. And so once you've made the circle, even though the process is kind of complicated, using it is pretty easy. Okay, last one, I want cosine of 0 and sine of 0. Well, remember, 0 degrees, that's your starting position. So you'll look for 0 degrees on your circle. That would be right here. And at the start, at 0 degrees, I'm at 1, 0 is my ordered pair. Then my cosine is 1, that's the x value, my sine is 0. So my cosine is 1, that's the x value, my sine is 0. Okay, last couple ones of these. I want cosine 210. Find 210 on your circle. So this is 0, 90, 180, 210 right here. And then at 210, my cosine is -√3/2. And my sine is -1/2. Okay, remember, cosine is the x value at that spot, sine is the y value. Next one, I want cosine of 300. Well, then I'm going to find 300 on my circle. Cosine is the x, sine is the y. So 300 is here. My ordered pair is right here. My x is a 1/2. My y is a -√3/2. 1/2 and -√3/2. Okay, last one like that. I want cosine 135. So this is 0, 90, 135 is right here. My x is a -√2/2. My y is a +√2/2. So my cosine is -√2/2. Y is +√2/2. Okay, now let's say you get an angle that's not already on your circle, like let's say -30. Okay, on my circle, I have a regular 30, but I don't have a negative. Then all that you need to do is get it back into standard position so that you know where to look on your circle. And remember, if it's too small, you're going to add 360 to that. So -30 degrees plus 360, that means that I'm going to use 330 on the circle. Okay, and so then you'll go to 330 on your circle. That would put me right here. And then for cosine, I want the x. So it'd be √3/2. Versus my y for that one is -1/2. So if your number is too small, you're going to add 360 back to it. Same thing on this one. -90, that's too small to be on my circle. But if I add 360 to that, that means I'm really going to look at 270. So let's put here, use 270 degrees on the circle. Too small, so plus 362. Okay. So then find 270 on your circle. 270 is straight down. And then I see that my x is a 0, my y is a -1/2. Oh wait, sorry, -1. Okay, then hopefully you get the idea. Let's change this last one. Let's make it an angle that's too big. Let's make this a 420. Okay, you would say, oh no, 420, that's too big to be on my circle. Well, then remember, if your angle is too big, you're just gonna minus 360 off that. And then that'll tell you where to go to on your circle. So if I do 420 minus 360, that means I know I really want to use 60 degrees on my circle. Okay. And then I'll go to my circle, find 60 degrees. Remember, cosine's the x, sine is the y. So 60 degrees would be right here. My x is a half, my y is root 2. X is a half, y is root 3 over 2. Okay, and then I'm just not. All right, so hopefully we kind of have the right idea on that. I am going to do maybe 1 or 2 questions off the homework just to make sure you kind of understand what's going on. So go ahead and pull out your Delta Math. Go ahead and log in there for me, please. And then I want you to find this section right here. So I'm going to skip the positive and negative coterminal angles, and I'm going to start right here. So this is question number 5 from the top. Okay, so it's asking you to find the cosine of 300 degrees. So the first thing that you need to do is find 300 on your circle, and then you're going to move this green dot to that same position. So 300 degrees would be here. I notice that I'm 1 click away from straight down. That's 300. So I'm going to take my circle here. I'm going to go all the way to straight down. And then I'm going to do 1 click over. Don't go 2 or 3 clicks. You want to be only 1 click over. Okay. Then as soon as you do that, this little box down here is going to pop up. That is going to let you type in your answer. Remember, cosine is the x value on the circle. So if I go to 300, I see my x value is a 1/2. So you're going to move the dot first, then type in the answer second. Okay, let's do 1 more. Okay, this is now question number 6. I want sine 240. So I'm going to look on my circle for where 240 is. 240 is right here. And I notice that it's 1 click away from the y-axis. So if I go all the way down to the y-axis, I want to go 1 click backwards. Okay, and there's only 3 spots in each quadrant. So you just want to make sure this would be like 1 spot, 2 spot, 3 spot. You know what I mean? Okay, then from there we want sine. Sine is the y value. So if I'm here at 240, I see my y value is negative root 3 over 2. So I'm just going to type that value in here. So I want negative square root 3 and then over 2 like that. Okay. All right. Hopefully that's enough help for you to get through today's homework. You should only have sines and cosines. Remember, sine is the y, cosine is the x. Okay, you can do it.